In this problem, we are going to write a function for school population again, but we're going to answer a few additional questions. In 2004, a school population was 1,001. By 2008, the population had grown to 1,697. Assume the population is changing linearly. Show your work for each of the following. We want to find a linear function model for the population of the school as a function of years after 2004. So, we know that we are looking at a function. We'll call it f of x. The initial population was 1,001. And we're adding what? We're not explicitly told how many students it is increasing by per year, so for now we're just going to call it m. In my red ink, I'm going to go ahead and calculate our m, which is our change in y over our change in x, our change in outputs divided by our change in inputs. So in 2008, we were at 1697. We're subtracting off 1,001 and dividing by the difference of our inputs, making sure we keep the same order. 696 over 4, and that gives us 174. That's our slope. So our updated function is now f of x is equal to 1,001 plus 174 students per year. So what is that slope? What does it mean? The slope is positive, so it means that we're increasing the number of students. So this slope is telling us that the population is increasing by 174 students per year. What is the vertical intercept? The vertical intercept happens when our input is 0. If our input is 0, our output is going to be 1,001. What does this mean? The population started at 1,001 students. We're going to use our model to predict the population of the school in 2016. So, year 0 was 2004. So we'll say 04, our x was equal to 0. In 05, it was 1. In 06, it was 2. In 07, it was 3. So it looks like whatever year it is, we're just going to subtract 4 off in order to find our input value. So 2016 minus 4 tells us that that's going to be year 12. So we're plugging 12 into our function. I'm going to go ahead and put that in my calculator. And we get 3,089 students.